Okay, today is kind of a second day of the same type of problem, right? So what I'd like to do is we've got some things that were due assigned for today, and that was to set up the problem, right? We had some solutions like 2.8 molar strontium nitrate, and I think there's like ABC all the way through F. And to set up all the equations you need, right? If you end up having 5 species, you need 5 equations. So I'd like to see if there's any questions on that, because the rest is just going to be math and plug and chug. So I'd like to see if there's any questions on that and knock those out, and then we'll take the quiz for today, because that's what this is on. And then we'll see how far we can get solving problems after that.
So I might have a question. So you have to have the number of equations as you have
Unknowns, variables,
no,
yes. Species.
species from just the original, or like the total for because like example C, we did 2 equations. Is that just because we had sodium and fluoride? Is that why we had 2 equations?
We have 5 equations. Yes.
So the number of equations has to match number 1, step 1.
Yeah, the number of equations have to match the number of unknowns and number of species. Yes. So in, for example, in C, we've got 5 species, so we need 5 equations. All right.
What was that?
For D?
Yeah.
Okay, for D. So what? Let's start identifying the species. What would be the species present? Oh, good. H plus, Cn minus, OH minus. See, in some of these, you like if I get into my little mode, I wouldn't even be writing OH minus yet. I wouldn't. I'd figure it out though when I write the KW. Oh, now I need OH minus, right? But that's kind of how it goes.
When you get to there, I'm not too sure, because I just assumed that there was an OH1.
But you're right. But logic dictates for me. Logic dictates for me the H plus, the Cn minus, and HCN. Right? That's what I would pretty much be writing first if I was just starting this out. And the reason why you write HCN is because it's a weak acid, so it's definitely going to exist. Most of it is going to be in this form, in fact. Okay, and then you go on to the next steps, and you start writing the chemical equations. So you'd be writing a Ka reaction because it involves a species. And then you see, oh, I have H plus, so I have to write a Kw equation. And that's when, Jamie, the hydroxide pops out, and you realize, oh, well, so it has to be Kw. You have to write a Kw expression. Yeah, you should write that one too. But see, the Ka doesn't have OH minus in it. It just has these 3 in it. And then you realize, okay, what other expressions can I write? I can write Kw. And then, Jamie, that's when I realized, oh, I forgot about hydroxide. So if you can really see ahead, you might write hydroxide right away. But because essentially, whenever you have H plus, you're going to have OH minus. Whenever you have OH minus, you're going to have H plus because of the Kw expression. So you don't have much choice there, really. But you need to do a few to kind of catch that.
So on like C, how did we end up having H plus and OH minus?
On C, because we wrote the Ka expression.
Yeah, I wrote the Ka.
And then you have H plus, and then so we added that to our list, and
So for D, I ended up then with 1, 2, 3, 4, 5 equations, but only 4 species.
okay, hang on. If you have more equations than species, that's fine. So I don't think we're missing anything, right? Yes, you have 4 species.
Wait, if you have more.
Well, 2 of them are going to be redundant. If you look at them closely, 2 of them are saying the same thing.
Yeah, so that's.
So really, you only have 4 equations.
Okay.
But we need to list them all out for you to see it.
So then in example C, where we had 5
Well, let's hang on. Let's finish this out so everyone can follow what you're saying, Matt. Okay? The Ka expression, everyone, right? Products over reactants. H plus, Cn minus, all over HCN, right? And then we ended up writing the Kw. That's our second one. Then what was next on the list? Charge balance. So all the positive cations on one side, anions on the other. Let's see. So it'd pretty much just be these. And hydrogen cyanide doesn't show up anywhere, right? Because it's neutral. And everything has a 1 charge, so everything has coefficients of 1. Okay. So now we've got 3 equations. Now we're missing mass balance. And so you can say, what? How did you write your last? See, now we have 3 equations, only one more.
H plus and
hydroxide. So are you just looking at H as being your H plus?
Okay, now H is funky. Don't worry about H. I would focus on the cyanide. Because it's a lot easier to see. Because all we need is one expression. Cyanide, I have to say it in English, otherwise I don't do it right. Cyanide in all its forms is equal to what concentration? 2.1 And the reason why I have to say that is because sometimes there's a stinking little 2 down here, right? And then you have to say cyanide in all its forms is, you have to multiply it by 2, right? See, otherwise I might screw up there. So Cn minus in all its forms is 2.1 times 10 to the negative 6. Okay, so that means 2.1 times 10 to the negative 6 is what and what and what? Concentration of HCN. And is there any other cyanides?
Yes.
Yeah, and cyanide. There you go. So that's our 4th equation.
Can I ask you?
Yes.
On an exam, would you want us to write the concentration of all those?
No. This is my little, Matt, this is my little guarantee. This is my little, what do you call it, safety net? Or my little, I don't know, helper. Otherwise, I feel like I mess up. But in working pretty much all problems that have multi-steps like this, it's really, really good for you yourself to get in your own little mode, whatever it is. This is my little mode. You don't have to use my little mode, but it helps. Otherwise, because I like to follow logic, and just throwing hydroxide up there right away doesn't really follow my logic. I could, but it helps me minimize the number of species and the number of equations if I don't put something up there until I need it. So that's how I do it.
if you were to write that final equation, the mass balance one, could you write it in terms of H? Or would you just not even bother doing that?
H is,
Because we wrote down another equation.
I think H probably isn't good one to follow because of what? What's your solvent? You're in water. So what do you do with H2O? So H isn't a good one to use. And I guess the math is just saying stop. Don't even worry about anything else.
So when we have just H plus, forget it, or don't worry about the mass.
Well, I guess what I would say, Matt, is I wouldn't ask this question with what ion.
H plus.
Don't ask it with what ion. H plus. Just don't ask that question because you have water. It's the solvent. It's messing everything up there. And you're never going to need it. Don't worry about it. Follow a method where you stop when you get the number of equations that match the number of unknowns.
So then on the next one, where we have hydroxide, we
Try it. Try it.
well, there's no molarity, so
Okay. So what species would you start writing out here? Good. Aluminum 3. Aluminum 3. And Daisy says OH minus. And yeah, you're gonna end up writing a KW, so you're gonna need H plus. Might as well just add it now, even though I like to do it later. Fine, Javier. Anything else? Now again, when you're writing species, it's species that show up in a K expression. H2O liquid never shows up in a K expression, even though it's a species. Solids don't show up in any K expression known to man. Their concentrations are constant. They're thrown in with the equilibrium constants. So I would write a KSP reaction, KSP expression. Okay, you'd have that one. And then you'd write a KW expression. You'd have that one. Is there another expression? Yeah, because now we're kind of off of the K ones, right? Because the only other choice is Ka. You can't. So someone said, I think they like to do charge balance first. I don't know why. I think maybe because I think I put charge balance first because it's just easier. Okay, so all the cations on one side. Anions on the other. And it's a 3 aluminum. Good. Make sure you realize there's a 3 right there. Okay. So, hey, can we quit?
I did the mass.
Can you quit?
Yes.
Yeah. You can quit.
So,
3 equations, 3 unknowns. Okay.
so let me ask you. In B, we made a statement that the concentration of fluoride is twice that of lead.
Where are you at? Okay, yes.
So would we do something similar in other examples where there's no like polarity given, or?
If you need to, yeah. The problem is, look at this. Are these guys coming from the solvent? Either one. Lead or chloride? No. So I think when you start talking about components of the solvent, life isn't so nice and neat. So I wouldn't even touch it. Right? Don't even go there. Because I can see what you're saying. The concentration of hydroxide is 3 times that of aluminum. The problem is that hydroxide has several sources. It's also coming from water. So, and we have the KW expression, so we should be okay with that. But I don't know. It'd be interesting, Matt, to see if that would work out. It's just that the source of hydroxide, because I guess you really can't say this. The concentration, I think you really can't say this, because if your sole source of hydroxide was aluminum, you're correct. That mass balance works. But your sole source for hydroxide is not just that solid, and that's why you can't say it. So I think with mass balance, these guys are dangerous to work with. But you never need them, because if you keep track of your number of your unknowns, it's always going to work out. You're not going to need to worry about hydrogen or hydroxide in mass balance. If you keep track of your number of unknowns and number of equations, you'll never get there.
And they don't give you any sort of concentration.
No, they didn't, but we don't care. We're done. We have 3 unknowns and 3 equations. Okay. Okay? Right, Jenny? Oh, there's another one? Oh, there's potassium chromate. Okay. 2.1 molar potassium carbonate. Sorry, not chromate. Potassium carbonate. Okay, all the species. Potassium. CO3 minus 2. Yeah. See, so you're starting, you already see what's going on. But for me, in my little mode, I would start writing, oh, let's see, I can write a Ka expression with carbonate in it. So I'd write that Ka expression. Oh, more stuff popped up. So I add them in here. I can write another Ka expression, right, to see that. But if you already can see it, you don't really need to do that. But to me, it just made more sense. Because all those guys would have showed up. Okay. Oh, yeah, for KW, yeah. But for me, it kind of helps not to write all this stuff right away, because you need to write the Ka expression anyway. So I would have, if I was doing this on my own without you guys watching, I would have started with these two, and I said, oh, carbonate. Okay, I can write a Ka expression with carbonate in it. That's going to involve this guy, right, going to H plus and carbonate. So I can write its Ka expressions. I had to write the equation, otherwise I might screw up writing the Ka expression. Right? Products over reactants. And then I would have added this one and that one. And then I'd write another, oh, now I introduced him, I can introduce another Ka expression. Right? So I guess that would be, yeah. Because what Ka expression can you write with carbonate? Carbonate has to be the conjugate base. So when I see carbonate, I say, if I attach an H to him, is he a strong acid? Because if it is, I can't write that conjugate acid. But no, he's not on the list. So I definitely can write him. So there's my conjugate base. There's my conjugate acid. And then I end up writing hydrogen carbonate. Oh, okay. If I add an H to it, do I get one of the strong acids? Nope. So that means I can write another Ka expression. So I do that. Okay.
So the other K expression would be your HCO3 minus as your product.
Yes. Perfect. The HCO3 minus would be over here. Yeah. I guess if you want to do traditional numbers on these, but you'd have to look them up to see what those numbers are. And they call this 1 since that's the first hydrogen to come off. That's the tradition or the convention. But you'd see when you looked them up because you'd have to be given those numbers. All right. So there's our Kas. And we can write our Kw. And then we'd have to write our charge balance. Right? So here's 1, 2, 3. You'd write charge balance. Make sure you have nothing neutral in there. Right? And then, let's see, what else am I missing here? Oh, right? 1, 2, 3, 4, 5. I need 6. I need 2 more. So I better get 2 out of that mass balance. Okay, what can I get out of that mass balance?
4.2 equals the concentration of K plus.
Good. 4.2 has to equal the concentration of K plus in all its forms. Well, that's it. There's no other forms for K plus. Good. And 2.1 molar has to be carbonate in all of its forms. So wherever you see a carbonate, 1, good. There's 3 of them. Wherever you see a carbonate.
Are we going to we already did the charge
You can write it. I'm not. It's easy enough.
When you're doing the charge, you leave off the H2CO3.
Anything that does not have a charge doesn't belong in charge balance.
Okay.
Because think of it this way. You always multiply the concentration times the charge. What's the charge on H2CO3? 0. So 0 times its concentration is 0.
So when you're doing the math, because what I've been doing was just getting the charge balance and then inputting those items, those species, into my math.
No, here's your species. You got to worry about your species. That's everything. Whether it has a charge or not. Those are your species.
Do you do a KSP then for your potassium carbonate?
Oh, good point. You might be really, really tempted to write a KSP.
That would be wrong.
But it's wrong. Why?
Because it's a
Group 1. So you could be writing a KSP for it, and then you're trying to look it up and you can't find it. So to me, it just saves a lot of time to remember, oh, group 1, never. Right? And then it helps also to remember nitrates and ammonium, also, never.
But if it was a non-group one, then you would write a KSP.
Then you're going to have to look one up probably, right?
mass balance. You have to look at those original subscripts.
Okay. Ready to give this a shot? Just got to put everything away.
For your charge balance,
Mm-hmm.
you have the negative charge on it.
Yeah, it has to be 2 times it. It's always the charge times the concentration. It's always the charge times the concentration. Don't forget, not the negative sign. It's always the charge times the concentration, the absolute value. And once you get done, go ahead and work on your homework. We have to start solving these. It's listed on the bottom of the handout. Which ones I want you to solve. Let's see if I can count. I don't know. So if you don't have your handout, here's the one we're working on. Those guys. And you're done with the quiz.
So we're not bringing this in with our quiz.
Yeah, you can turn it in. Oh, yeah, you'd miss the questions, wouldn't you? Yeah, I guess we better not. Yeah, if you have some homework to attach, that'd be great. Otherwise, I can't give you any extra credit points there. Not really extra credit, easy points probably would be better said. See if I can get
equations.
Well, you can turn your homework. You just can't turn in that. You won't have these questions. You can turn in everything. But you can turn in everything else. So go ahead and start on this first one, it's EX2. And I'm giving you the numerical answers. So you see what I mean?
I'm still not sure.
Because to verify, if you have 5 unknowns, you have to
Oh,
have,
that's your verification.
you have to you have to make sure you have the right number of everything.
Okay.
Yeah, you did it. See, 1 0 5.
Okay. I was thinking, oh, can you solve it? But you need like a K8 actually.
Mhm.
You need
Just
one
verify.
eye to solve it.
Verify. Don't actually do it.
See, when I think verify, I always think solve.
Verify just means. Oh yeah, I get.
Like-
I
like
guess
a-
some
like
some
a-
English.
Like a proof. You know,
Yeah.
you're verifying.
Yeah. Yeah, I see what you mean.
Thinking math version. You know.
But yeah, 5 equals 5 is a proof, I guess.
Yeah.
That's the proof. Okay.
Yeah.
I did that worksheet on a separate sheet of paper, so do you want it or do you want me to
Yeah.
just hold on to
Yeah.
it?
So that way you get some points. So once you turn in the quiz, see if you can knock out your homework. Here's the first one. So I have the numerical answers up there. And just follow the steps. You're going to see you're going to need to use the quadratic formula to solve it once you get that far. I'll be glad to set it up or ask the folks around you. Be glad to help you. Mhm. Mhm. You do what? Yeah, you have to. You have to because he's the conjugate base of a weak acid.
This gives me a clue.
Yeah, yeah. When I see a negative,
You have to write two more.
well, just be careful because I could give you sulfate, and then you can only write the HSO4 one. You can't write the H2SO4 one. Yeah, because H2 is, but HSO4 isn't. Well, that's really kind of a trick question, though. But I think so.
So it's
Well, you can tear it out if you want. You're way ahead.
she turned in her sheet
Oh. I thought the it was something else. Oh, okay. So if you're not sure how to set this up, just ask so I can help you out. If you've already turned in the quiz anyway. Okay. So yeah, but don't. Oh, you did. Okay, you started up here. So write out the speed. Great. And then, oh, but you can't do this one because yeah. So don't just cross it out. Definitely can do that one. Okay. Charge balance. Okay, now we have 1, 2, 3 unknowns. You have to do mass balance. Okay, so what would you write for mass balance? Yeah, remember H, you don't touch him though. But so just try the other guy. In all its forms. Has to equal. Has to be that. And you don't multiply it by 2 or anything because it's not HCl2. So it just has to be that. So that means concentration of Cl minus. And there's no other forms of Cl minus. Has to be 7 times 10 negative 8. And that's one of the answers. See? Concentration of chloride is 7 times 10 negative 8. So now you've got your 3 equations and 3 unknowns.
So then I would do, oh, okay, so that's the only one I do?
Well, concentration of chloride equals this. So that's an equation. Bracket Cl minus equals that number. So now you can just start substituting, right? You can substitute that number into here, right? Solve for, I don't know, one of these two. Either, like, solve for H plus. And then you have Kw over H minus. So you put Kw over OH minus right here. And then you have to multiply through by OH minus. It's going to end up looking like AX squared plus BX plus C equals 0. Or X would, well, just get that far.
Yeah,
and then I'll help you out. Just, yeah, it'll be a lot easier if you get that. Get there first. Okay. So now we got to start solving for stuff, right? Now we know this is 7 times 10 negative molar. We don't know this.
We don't know what
H. With mass balance, you can't be using the solvent.
Oh, okay.
It messes everything up. So you pretty much,
This is Cl.
yeah, so cross this one out. Because H plus, because what you're saying, if you say this, you're saying the sole source of chloride is HCl, and that's agreed. It's pure water. The sole source of H plus is HCl. No. You have water deprotonation. This is saying it right here. So you can't write that one. But you don't need to. 1, 2, 3 unknowns. 1, 2, 3 unknowns. Okay? So substitute that number in like up here for the chloride. Right? But then you have, right? Yeah. Now you know what H is. So let's substitute this whole mess in for H. And then you're going to have one equation with one unknown. See that? So did you get this EX2 set up? No? Okay. So hopefully you identified your unknowns. Right? Where you need to find H plus, Cl minus, and, well, here. Just those two at first, right? And then you look at what K's can you write. All you can write is the KW. Oh, now I need a hydroxide up here, right? Fine. Okay. Are there any other K expressions? Mm-mm. So then you move on to what balance? Charge. Do charge balance first. It's easier. H plus. That's the only cation. I have two anions. Okay. Well, I've got 2 equations. 3 unknowns, though. Have to do mass balance. So we write, and again, what do we not touch with mass balance if you don't have to? Don't touch anything that has to do with the solvent because it's not the sole source, right? That's the whole idea of the mass balance, the source idea. So the chloride in all its forms has to equal 7 times 10 to the negative 8. And it makes sense because the sole source of chloride is the HCl. The sole source of H plus is not the HCl. Yeah, a lot of it's come from the HCl, but it's also coming from KW. So you can't, that's why you can't write it with anything to do with the solvent. Okay? Now we've got 3 equations, 3 unknowns. Should be solvable. It might have been a while since you've done something like this though, right? Okay. What I would do is I would substitute 3 into, because this one's done already. So I'd substitute 3 into 2. And there's a lot of different ways to skin this cat. Right? So then you'd end up with H plus equals chloride and hydroxide. You can call that equation 4. Okay. Oh, I forgot the chloride. 7 times 10 negative 8.
And can you make the assumption
Okay.
that it's a fair split of the 10 to negative 14?
We're not making any assumptions now. And everything has to be done full. No approximations, no dropping anything. Now we know what the hydrogen ion concentration, but it still has 2 unknowns in one equation. So you got to keep substituting. So you keep playing that game of substituting until you finally get one equation with 1 unknown in it. Right? That's the name of the game. So this is already solved for H plus. So let's substitute 4 into 1 because we haven't used that one yet. Okay. So that would end up being KW, right, which is 1 times 10 to the negative 14, has to equal hydrogen ion, and we said that's this mess. 7 times 10 to the negative 8 plus hydroxide. Okay. And then that's the hydrogen ion concentration. You have to multiply it times hydroxide again. Right? If I substitute it in. Okay. Now I have 1 equation with 1 unknown in it. If I back up a little bit, so you can solve it. But if I back up a little bit, why did I substitute 4 into 1? Because if you go back and substitute into one of the equations you've already used, you end up with, like, remember getting like 1 equals 1 or 6 equals 6 or something? That's what you're going to end up with. No new information. So you got to substitute back into the equation you haven't used yet. Okay. So if you multiply through by hydroxide, man, that looks just like this. Right? multiply through by that hydroxide and bring the 1 times 10 negative 14 over. It'll fit perfect into the quadratic formula. Try it. And you should get those answers up on top.
I'm sorry, is it possible to roll it down just a bit? I'm looking for it.
Sec. All right. Yeah, nice. Mm-hmm. So now, looking at that, you can see what A, B, and C are.
So you lost me. I'm with you right here. I got you. But then
Okay.
you lost me.
So now I know. So you know what? This is the hydrogen ion concentration. So this is equal to that 7 times 10 negative 8 plus the hydroxide concentration. But you just substitute in for this. You still have to multiply through by that guy. So if you multiply through by him, you'll have hydroxide times that number plus hydroxide squared.
So
Because hydroxide's like your x. If it looks easier, you can just replace hydroxide with your x. Yep.
Is there any particular reason why you moved the 1 times 10 negative 14 over to the other side?
Oh, because it has to be in this format. 0 has to equal it. To get in the quadratic formula format, ax squared plus bx plus c has to equal 0. That's why I got to bring it over. Yep. So my a would be 1. My b is 7 times 10 to the negative 8. My c is a negative 1 times 10 to the negative 14. And you don't have to solve it this way. There's other ways, but don't forget to divide by 2a. Which is just 2, yeah. If you got it, try the next one. See how far you can get on your homework.
Because I solved it not using the quadratic. I
How would you
just
solve it?
algebraically. So as if this was an x value. This was
Okay.
X, and this was x. So leaving this over here.
But you can't call those both x. These two are two different things. you can call this x and that y. But you can't call this x and that x.
Well, isn't this, well, this is still,
Because if you want to do algebraically, you're saying let x equal something. So
couldn't I
let
subtract?
if you want x to equal this, well, x doesn't equal that then. Still, if you by doing that, you just introduced more unknowns in the equation. It's easier just to leave it alone. You only have one unknown. So multiply through by your hydroxide.
Because, okay, so if I left it at, I'll just do the quadratic.
You don't have any choice. I really don't see a choice.
Ended up getting an answer, but it's,
The answers are written up on top. Oh, they were. So did you see the numerical answers written up there?
Wait, no. I got 1.32 times 10 to the negative 7 instead of 1.4. Does that make a difference?
You messed up somewhere. Let's see where you did it.
I didn't
Squared
round
minus
anything.
4ac. No, you don't. Yeah, don't round anything. Would it be? I don't know where you would have. Did you divide by 2 and stuff? I don't know.
I added these two before
Did you
I
take the
divided
square
them.
root? It has to be negative b. You have to take the square root of this whole mess.
Yeah, which is 2.2. Where's 2.2? Yeah. That's the square root of. Yeah, and then
Okay.
before I divided
Now
by
you,
2.
yeah, it's plus or minus. So you can add them
And then I add
and divide by 2, or subtract and divide by 2. Two possible answers. And one of the answer doesn't make sense. One answer will be nonsensical. So remember when you're doing the quadratic formula, it's plus or minus. It's the b plus or minus. So that means one of your answers is going to be nonsensical. Right? One of your answers won't make sense.
I didn't know, right, but those are my answers that I got. Like, did I mess up somewhere?
B squared minus 4ac. Okay, you took the square root of this and you got that?
Yeah. Is that where I messed up?
I don't know. I don't have a calculator brain, but it looks good. So you can add them or you can subtract them. And then divide by 2. Add it. See, look at. See how you're missing your divide by 2
I
part?
divided it by 2 over here, and then I did this.
No. That's outside the square root.
Oh, that's right. Okay, so.
See how the dividing by 2? That's outside the square root. You divide your final answer by 2. Okay, we're about out of time, but give the homework a shot. You should have a good shot at it. Notice the last step that 2 is on the bottom, the 2a.
4.49?
Yeah.
I think make sure that you put the square on the outside of the first parenthesis, and then just making sure that your negatives are right on the square root. Yeah, and then second root. 2.11.
Yeah.
Times 2 to the negative 7. So then you have that for your